Now we can go ahead and do example 4, which is a multivariable function. The question reads, suppose that C of xy is the cost in dollars for a fabric manufacturer to produce X yards of cotton fabric and Y spools of cotton thread each week. They are currently producing 30 yards of cotton fabric and 50 spools of cotton thread. Question or part A. With this production level, at what rate is the cost increasing as they increase the amount of cotton they make? So here's the important part. We're used to the rate of increase. They're asking about the cost function, which is the only function we have. But the important part for us, it says as they increase cotton fabric, because we can only look at it for one variable at a time. Cotton fabric is for us the x value, so we're taking the partial derivative of the x function. Really important to focus on, who am I taking the derivative of? Cotton fabric, and up here it says x yards of cotton fabric. So going piece by piece for the derivative, that 100 would have a derivative of 0 because there's no x. 0.5x will have a derivative of just 0.5. The 0.35y will have a derivative of 0 because it does not have an x. The 0.1x squared will have a derivative of 0.1, well, times 2x to the 1 power, but you probably just wrote 0.2x. And the last term does have an x. So when we take the derivative and that x turns into a 1, we have a number multiplied in front and a number, or in this case a variable, multiplied in back. So when we clean this up, we're looking at 0.5 plus 0.2x plus 0.2y. Just like before, we're not done because we need to look at the fact that they're currently making 30 yards of cotton thread, and cotton fabric, which we said is x, and 50 spools of cotton thread, where y is spools of cotton thread. So we need to evaluate our function at 30, 50. And so when we plug in the 30 for x and the 50 for y, we have 16.5. Now again, we need to watch out for the units. We were taking the rate for the cost based on cotton thread. And since the cost per fabric, or cotton fabric, is still dollars per yard, right? Cotton fabric is measured in yards. Then our final answer is $16.50 per yard. Part B. With this production level, at what rate is the cost increasing with respect to the amount of cotton thread they make? So rate of cost increasing, but this time we're focused on thread, where we're given that y is spools of thread. So we're taking the derivative of the y value. So the first term, 100, does not have a y. There is no y. The next term of 0.5x will have a derivative of 0 because it does not have a y. The third term of 0.35y, that one will give us a derivative value. The 0.1x squared, again, will get a 0 because there is no y value. But the last term does have a y value that goes to a 1. So our final derivative is 0.35 times 0.2x. And again, we need to evaluate it for the 30 yards of fabric and the 50 spools of thread. So plugging the 30 in, notice there is nowhere to put y equals 50 because there is no y value. That's fine. We get 6.35. And this time for the units, we're doing the cost, and we know that the cost is in dollars. But remember, the y is in spools of cotton thread. So, there's cost in dollars, and y is in spools of thread. So $6.35 per spool. Part C, this asks for the production level, which is the marginal cost to make the cotton fabric. So notice it's to make, not approximate. So we're just taking the partial derivative at 30 and 50, which we already know is 6.5 from part A, and we know that the units are dollars per yard. Part D asks us again the marginal cost to make cotton thread, so not to approximate. So we want the partial derivative of y evaluated at 30 and 50, which we know is 6.35 from Part B, and the units are dollars per spool, just like they were in Part B.